All right, there it goes. So, new unit about geometry, and this is the first day, and the topic, probably figured out already, is types of angles. If you look on the screen, there are all different types of angles, and hopefully by the end of this video, we'll be able to sort out what the various types are, how they mean, what all this is all about, and try to straighten things out. So, let's get started. Okay, so one way that we classify angles is by their size. The measure of the angle is what we would typically call it, and the words that we associate with that are acute and obtuse and right angles. You've seen these words before, and you probably have a general idea of what they are. So I'm just going to kind of go right to it. So acute angles are angles that are between 0 and 90 degrees. Okay, obtuse angles, they would be between 90 and 180. And then where do the right angles fit in? Right there, exactly 90. Okay, so put a couple of words there. Okay, so the angle, that's angle, is less than 90 degrees. Angle is more than 90 degrees. And we all know a right angle equals 90 degrees. Okay, we don't have an angle that's less than 0. We don't have angles that are more than 180, because by the time we get to more than 180, we're bent in the other direction. Okay, so keywords: acute angle less than 90, obtuse more than 90, between 90 and 180, and then right angle is exactly there. Okay, so that should be new, shouldn't be anything new. Complementary angles. These two angles are complementary. And we can check that out if you want, just to get ourselves a reminder of what complementary angles are. Do a little angle measurement action. Okay, protractor. This angle looks to be about 56 degrees, we're going to call it. 56 degrees. And then we'll move over to an angle over here. Okay, we line up the little centerpiece right there at the angle. That one appears to be about 44 degrees. No, 34 degrees. How about that? So this angle is 34 degrees. And if we notice the two of them, oh, what happened? Let's just get rid of that thing. Boom. The two of them add up to 90 degrees. Okay, so complementary angles, two angles, the total is 90 degrees. Okay, I can just take these angles and just give you the visual on that. If I spin this one a little bit and slide it on over here, okay, looks like about a 90-degree angle when I match them up. Okay, probably could get that protractor back out and measure that it's 90 degrees. Complementary angles, two angles, the total is 90 degrees. Okay, the other kind of angle that we know about are called supplementary angles. I'm not going to grab the protractor and measure them. I'll just tell you that supplementary angles, if I line them up, and I believe I can, I believe I did, okay, these two angles right here add up to 180 degrees. Total is 180 degrees. Okay, so if this one was 105, this one would have to be 75. Okay, word of caution, when we draw pictures and give you information on any kind of problems, you don't want to look at the picture and go, oh no, it can't be 105 or that can't be 75. We just go with, whatever the math is. If I tell you one thing, you'd use supplementary to find the other. So don't assume the drawings are built to scale. Okay, supplementary angles. So question that sometimes come up is, how do we keep track of which one is which, complementary, supplementary, which one is 180, which one is 90? Okay, and here's my little trick. Going back to that first slide, if I have two angles that are complementary, what type angles must they both be? Okay, they must both be acute angles, right? Okay, with supplementary, I have an obtuse angle and an acute angle. I have to have that. But with these complementary angles, they're both acute. And if you tell someone you're acute, that's a compliment. Okay? So when you stop laughing, then continue forward with the presentation, where we'll talk about linear pairs. I'm on a different color. Don't know why. Linear pairs. If you look at this, this is a linear pair. okay? Angle HOE and angle POE. Probably should make some notation on angles that when we're talking about angle HOE and angle POE. So we just start with the letters and work our way around there, okay? They are a linear pair. They make a straight line, okay? And linear pairs are two angles that add up to make a straight line. So linear pairs equal 180 degrees, they're supplementary, okay? Supplementary angles. A linear pair is basically, I guess if I want to be technical, they're adjacent angles, which means they share a side that equal 180 degrees, that make a straight line, okay? So that's a linear pair. That may be a new word for you that we use, okay? A couple of quick questions. Are all linear pairs supplementary angles? Hopefully you're going true on that, because I think we just wrote that back here, didn't we? They're supplementary. Yeah, so there's our linear pair. So that one is true. Are all supplementary angles linear pairs? Let's go back a couple slides. These two are supplementary angles, right? But they're not a linear pair, so that one is false. Okay, moving forward. Vertical angles. Definition of vertical angles are non-adjacent angles formed by intersecting lines. We've got two intersecting lines, and I'm looking for the angles that aren't adjacent, and they don't have a common side. So 1 and 2 are adjacent angles. 1 and 3 are non-adjacent angles, okay? So, for instance, in this case, so angle 1 and angle 3 are vertical angles. Angle 2 and angle 4 are vertical angles, okay? So there's a special property that you might be able to tell by looking about vertical angles. Okay, I'm just going to tell you what it is, and then we're going to go about proving that it's actually true, that I'm not just making stuff up. Okay, vertical angles are congruent, and we've used that word congruent before. It means they're the same size and shape, they're both angles, and they have the same measure in this case. Okay, let's take a look. What do we know about angle 1 and angle 2? I'm waiting for you to answer, but you're not here. So angle 1 and 2 are a linear pair, right? Which means that angle 1 plus angle 2 equals 180 degrees. Okay, angle 2 and 3 are a linear pair. So that means the measure of angle 2 plus the measure of angle 3 equals 180 degrees. And the little m means measure. It means we're actually talking about numbers. You can't just add angles together. You can't add physical things, but we can add their numbers together. So both these things equal 180. So it's reasonable to say that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus, I'm going to squeeze this in, the measure of angle 3. Okay, since they both equal 180, they've got to equal each other. Okay, well, we might notice now, both sides of the equation have an angle 2 in it. So I can just subtract angle 2 from both sides, and I'm going to subtract it just by crossing it out. Subtract the same thing from both sides, and I'm left with the measure of angle 1 is equal to the measure of angle 3. Okay? Angle 1 and angle 3, vertical angles, they're equal to each other, and away we go. Okay? Making sense so far? Good, good, good. Corresponding angles. Got to get moving here. So corresponding angles, if you remember matrices, when we added matrices together, 1, 2, 3, 4, that's what that says, plus 2, 4, 6, 8, we added the corresponding pieces, the pieces that were in the same exact location in both matrices. So we'd add the 1 and the 2 and the 4. So when we're talking about corresponding angles, we're talking about angles that are in the same location in this place. So angle 2 and angle 6, they're corresponding angles. Okay, angle 2 and angle 6 are corresponding angles. Okay, you can find several more pairs, angle 3 and angle 7. Corresponding angles, angle 4 and angle 8. So same location in both things. Okay, angle 2 is above the line to the right. Angle 6 above the line to the right. Okay. The thing about these, if I have the two lines that are parallel to each other, then the angles are the same. So if L is parallel to M, then angle 2 is congruent to angle 6. Okay, we're going to hold off on that for a brief moment. Alternate interior angles, okay, that's like angle 3 and angle 6 are alternate interior angles. Angle 3 and angle 6. So they're alternate because they're on opposite sides of the transversal. That's what this thing here is called, a transversal. And they're interior because they're in between my two lines here. Okay? If L is parallel to M, so if L is parallel to M, then angle 3 is congruent to angle 6. So my alternate interior angles are congruent. Angle 3 is congruent to angle 6. Angle 4 is congruent to angle 5 in this case. Okay? Alternate exterior angles, not a big leap there. 1 and 8. Okay? Angle 1 and angle 8 are alternate exterior angles. And again, same reason, alternate because they're on opposite sides of the transversal, exterior because they're outside. Okay? Same story. If I have the lines parallel, if L is parallel to M, that means that angle 1 is congruent to angle 8. Okay? So we've got a bunch of terms. Consecutive interior angles. Interior angles, that's 3, 4, 5, and 6. Consecutive, well, it can't mean they're on the opposite side because we have a word for that. It means they're on the same side. So angle 4 and angle 6 are consecutive interior angles. Okay? Condition, if L is parallel to M, then my consecutive interior angles are congruent, are not congruent, they're supplementary. So if L is parallel to M, then the measure of angle 4 plus the measure of angle 6 equals 180 degrees. They're supplementary to each other. Okay? Oh, record moving pace here. Okay. So some typical problems that we would solve with this sort of problem. So we're just given an angle measurement. We're probably going to need to be told that L is parallel to M to make this all work. Angle 1's 105. Okay? Angle 1's 105. These two make a linear pair, so angle 2 is 75. These two are vertical angles, so angle 3 is 75, or it's a linear pair here. Angle 4 is 105 because, well, variety of reasons. Vertical angle here, linear pair there. Now to get to the bottom, angle 1 corresponds with angle 5, so it's 105 degrees. Angle 3 corresponds to angle 7, so it's 75, and then we can use our vertical angles to get these other measurements. Okay, problems like these, the thing is that typically they're going to give you one number, the other number is the supplement to it. They look like they're the same measure, they probably are. Angle 2 and angle 6 look the same, angles 6 and 7, so you don't have to overthink it, just the properties. Okay, a little more difficult problem, but still not so bad. Okay, angle 3 is 50, angle 11 is 42. Still need the condition that L is parallel to M. We have that, we can just start filling in. Okay, we know that in this one we're going to have bunches of 50s. Angle 2 is going to be 50, angle 6 is going to be 50, angle 7 is going to be 50. Going to have a bunch of 130 degree angles. Okay, and again, don't judge the size, 130, so all the rest that we haven't marked are 130. Down here, can have a bunch of 42 degree angles. Can have a bunch of 42 degree angles. Can have a bunch of 42 degree angles. Okay, and then the rest of them are going to be the supplement to 142, which I think is 138. Means I got about a minute to get rolling on this. We can do it. Okay, right? 42 and 38, 40 and 30. Yeah, so the rest of them are 138. Again, if they look the same, they are the same. Okay, these lines don't look parallel. They're not parallel. Okay. I was cruising quickly. We've got a bunch of words. You can slow it down and pause. But you see we've got all our angles now in somewhat of an order. Angle size, sort of how they add up to 90 or 180, linear pairs, vertical angles. All of these have to do with the setup, corresponding alternate interior, alternate exterior. These are congruent. Consecutive interior, see if I can get there, are supplementary, okay? And linear pairs are supplementary, okay? So lots of angles, lots of words, lots of vocabulary. Last question that I'll leave you with, how many different kind of angles can you find in this picture? Of the ones we just went through, stop, pause for a second, answer a few. It'll lead you towards the project also. Thanks for watching. Hope you learned something. we'll see you soon.